What's up? I'm Jesse. Welcome back to the Wolfram Tech Conference 2018. Like I've stated before, I'm just here talking with various developers or cool people using our technology in really interesting ways. Right now, I'm here with Carlo. So can you tell me like what you do here at Wolfram and like what your focus is on?
Oh, that's a hard question, really, because
Yeah, I know.
Wolfram is like a really interesting company, and I over the years I got to work on completely different things. My latest focus is on integrating relational databases with the Wolfram language, and it's been a really challenging project, one of the longest I've worked on. It's not done yet, but we're excited because it's like really the first time that we're bringing out of core data science to the Wolfram language. And it was a very important missing piece, and I'm proud to be involved with it.
Cool. Well, can you tell me a little bit about what you've been doing to integrate Wolfram language with databases? I know we've had database link sort of in the language, but is this different? Is this better?
So you say we had database link sort of in the language.
Yeah.
I think that sort of is very important. Database link is like an external package, and as such, we feel in general that things that stay out of the system context have not been fully blessed. And so it's like they lack the level of polish that we expect from the things that are in the main language. And so, I mean, database link is a fine piece of technology, but in terms of in end user interface, the arguments of the function, and so on, it still feels a little bit different from the rest of the Wolfram language. And as such, now we are trying to get a more modern approach to talking to a database. There are still some things that database link does more than we do right now. For example, database link has capability to write to a database, which we don't yet. But database link is more low level. You often end up having to write raw SQL, and that's somewhat unfortunate. I mean, why wouldn't you write it directly in SQL at that point?
Right.
Why go through Mathematica, the Wolfram language, or Wolfram desktop? So that's the main difference, I guess.
Cool. Yeah. So how does Wolfram language and SQL interact with each other?
Okay, so it is a feature of many programming languages, especially object-oriented programming languages, to have something that is called ORM, or Object Relational Mapping. Obviously, we cannot have an object relational mapping in a language that is not object-oriented. And so at some point, there was a moment of realization that that happened at the same time from my team side and from the part of Wolfram Research that's working on the knowledge base in Alpha, that the way we represent knowledge in Alpha could blend well with some sort of symbolic ORM. And so the idea is that you have something that represents a query in SQL, and it's fully symbolic, just like many things in Mathematica. It uses functional style nesting, but it stays fully symbolic. So you can manipulate it in many ways. You can use advanced programming techniques like metaprogramming to generate the query, and then it gets executed in one go in one simple block. So the design is rather simple and rather elegant. Of course, there are a lot of challenges in making that actually work because the SQL work is, I would say, a zoo. Many different situations out there. So, yeah, I guess the main problem is that there are many dialects of SQL, and within each dialect there are several versions, several levels of support, different syntaxes, and syntaxes that are in general not only different among SQL dialects, but very different with respect to the semantics of the Wolfram language. And so, like, the Wolfram language is very loosely typed, SQL is very strongly typed. though not all of SQL dialects are strongly typed. And so, like, to have something that feels natural when you're used to writing Wolfram language code is actually pretty hard. So,
And you
yeah.
would say that you were able to sort of blend this with SQL rather well for the user to feel like they're comfortable enough writing database queries.
Yeah, I think right now it feels very natural. Um, People don't really have to worry too much about the ins and outs of whether, you know, SQL has these very weird historical features like that derive from the fact that it was used starting in the 70s by banking corporations. And so, for example, to give an example, there's a way of storing numbers that is, I think, still exists only in SQL that is called decimal or numeric. So instead of the numbers being stored as floating point in binary, they're stored directly in decimal form, just like we write them down.
Right, yeah.
And that's because you absolutely don't want rounding errors when you're dealing with money. And so when you have dollars and cents, they have to be exact dollars and cents. And that's something that most modern programming languages don't support anymore, but it still exists in SQL. Should our users worry about that or not? Fortunately, the Wolfram language has extremely good precision tracking, so it's not a problem. But in there's a lot of engineering that goes into making these two things talk together.
Cool. So I guess we've talked a lot about sort of the technical implementation of how to get this to work. What are some common workflows that you see a user using this sort of technology?
So first of all, you need to connect to a database. So there is a symbolic representation of the connection, of the so username, password, what the host and the port is. Once you connect, the first step is inspecting the database to figure out what's in there. Then, once you've inspected the database, you only have information that's very raw SQL, and we lift that into an entity store that can be then registered and queried. Now, once you have the data in an entity store, I mean, the data is not really in there, it's still in the database. And it might be much, much larger than the memory of your computer. There are databases out there with terabytes of data, coming from everything from logs of websites to scientific data, especially in biology. They have now huge troves of gene expression and genomes and proteins and so on. So once you have the data connected through an entity store, you can perform queries that generally will make the data viable for usage within your machine. So obviously, Mathematica has thousands and thousands of functions, ranging from mathematics to geo-aware computations and so on. And most SQL databases don't support that stuff. And so, in general, what you want to do is like kind of aggregate the data or digest it in a way that it is small enough that you can then manipulate it with the Wolfram language. And so it allows for some kind of hybrid workflow where you deal with the really, really large stuff out of core completely, then you bring it in, and then you can use all sorts of visualization, or I don't know, you want to do some data arithmetic or maps and whatnot. You can integrate it with our own knowledge base. So, for example, if you have some data that is geographic in nature, then you can absolutely link it with things that we know about those regions, like the population and so on.
Right, yeah.
So, it's really, I think it's really nice how it all blends together because you can have a fully hybrid workflow, but it doesn't feel like you're using 5 different products or 5 different programming languages, as it would be if you were doing this with something else.
Yeah, the unification's like totally important, I
Yeah.
think, for any kind of workflow, not having to use any disparate tools. In the next few years, where do you see this technology heading?
I think that the first next step, the main next step, is to be able to write to databases. So we've had over the years several products that aim to let people, for example, log visits to a website. So in the past I've worked on things like form function, API function, and it's often a request of our users, like to be able to say, I want to do a survey. There are many people coming to my website, they enter data and they write it down. Databases are exceptional for this kind of thing because they're designed for concurrency and to preserve atomicity of the transactions. And so I think it will be very important as we expand also our capabilities on the cloud to let people write to the database. If you think about something like a website like, I don't know, Airbnb or Facebook, to us developers, a website like that is really a giant database with a little skin around it. This is probably somebody who does front-end development would feel insulted by this, but it is true that if you think about it, like when you go to Airbnb, like and you scroll around the map, then they are like doing some geofencing to figure out what apartments to show you that are in the map in that moment. All that stuff is stored in a database. And then there are tables for users, tables for trips, for financial transactions. If you break something in your apartment, they have to know, who to give the money to, and so on. So it's really very important for modern web development to be able to write to a database as well.
Cool. So do you have any other comments that you want to make about, 'cause you've exhausted all the questions I have for you. So do you want to ask or like talk about anything in particular with this new database technology?
Well, I think that, maybe I shouldn't be the one to say it, but I think that what we're doing is really, in a sense, groundbreaking because, there's a long history of integrating databases with object-oriented languages, but I've never seen something that, the Wolfram language is a very unique language in the fact that you can really manipulate everything. Code and data are the same thing. There are languages that are like that, but they usually are not as easy to use, or at least comes to mind. And so I guess that this is a new form of relational mapping. I wouldn't call it object relational mapping. Maybe it's like a symbolic relational mapping. And there is not much out there that looks like it. So I'm really excited. I think there are a lot of new ideas in this.
Yeah.
Yeah.
Cool. Well, thanks for taking the time to hang out with me and talk.
Thank you.